This is the third and final video on inequalities in triangles, and this one continues using the triangle inequality theorem. So again, the triangle inequality theorem simply says this, that the longest side of a triangle is always shorter than the other two sides combined. And in the last problem we did some sample problems where you were asked whether or not a triangle could have the following side lengths, and the answer was either yes or no. In this one we have a slightly different question, that is the lengths of two sides of a triangle are given and describe the possible lengths of a third side. So let's just do some examples here. In the first example, let's say that we had 7 and 4 and x. And the question is what could x be if this is a triangle? Well, the thing about this triangle is that x is either the largest side or it's not. If x is not the largest side, then 7 is the largest side. If 7 is the largest side, then that means that 4 plus x has to be greater than 7. So what number could 4 plus x be in order for it to be a larger number than 7? Well, it could be anything bigger than 3. So x could be bigger than 3 if 7 is the largest side. Let's think about that. If x is 3, it would be 4 plus 3 is 7, and 7 it would be equal, but remember the triangle inequality theorem says the longest side has to be shorter than the other two combined. So it could be a number which is larger than 3 if 7 is the largest. The other possible case is x is equal to the largest side. Now if x is the largest side, then 7 plus 4 has to be bigger than x. And in this case, x would be anything less than 11. Why less than 11? Well, if x is equal to 11, then the largest side would be 11. The other two sides combined would be 11 as well, and that would violate the triangle inequality theorem, which says the longest side has to be shorter than the other two sides combined. So x has to be both greater than 3 and greater than 11, and this is your final answer. X has to be greater than 3 and less than 11. And anytime x is within those two numbers, then you know it's a triangle. Let's do another example. Let's say that we had the same question, but now the sides were 5, let's call it C, and 12. In this case, 5c and 12, then either 12 is the largest side or c is the largest side. If 12 is the largest, then we know that c plus 5 has to be greater than 12, so c has to be greater than 7. If, on the other hand, if c is the largest side, then we know that 12 plus 5 has to be greater than c. In other words, 17 has to be greater than c. Put those two together, and the answer that you get, if c has to be greater than 7 and it has to be less than 17, then that means c is between 17 and 7. Let's do one more quick example. Let's say you were given 14, 3, and y. You can actually do this much faster. You know in this case that y has to be between two numbers. What are the two numbers? The two numbers are 14 minus 3, which is 11, and 14 plus 3, which is 17. And if you think about it, you convince yourself that that is exactly the same problem we did before. Anyway, now what you want to do is you want to do the practice 5.5 and see if you have any questions.